Hello, in this lecture we'll answer two questions. In the first question, we'll find out the radius of this quarter circle. In the second question, we'll find out the size of this angle, angle theta, that is inside triangle ABC. We'll start with the first question. In the drawing, we have a quarter circle, side VC or line segment VC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units, angle OBC, this angle equals to 90 degrees, angle BCD, this angle equals to 90 degrees, and this angle CDL is also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. Okay, so first of all, because of the fact that this is a quarter circle, we can conclude from it that from that fact that point O is the center of the quarter circle. I write it down. Point O is the center of the quarter circle. And also that angle B or F, this angle is equal to 90 degrees, and here side AO must be equal to side OF, and they are both the radii of this quarter circle, so we'll define the radius of this quarter circle as R. Therefore OA will be equal to R. It is the radius of the quarter circle, and OF will be also equal to R. Is the radius of the quarter circle. Okay. In the next step, we'll extend the straight line CD by a straight line until it intersects with the radius OF of the quarter circle, and we'll define the touching point of the extended straight line CD and OF as N. So by doing this construction, we created here quadrilateral BCOM. I write it down. This is quadrilateral BCOM, and inside quadrilateral BCOM we have 1, 2, 3 right angles. I repeat again, inside quadrilateral BCOM we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this angle that is actually angle DMO. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay, so here we got this equation. The sum of the angles in quadrilateral BCOM is equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we'll get that the missing angle, angle DMO, equals to 360 degrees minus 270 degrees, it is equal to 90 degrees. So the missing angle is a right angle. So this angle equals to 90 degrees, is a right angle. So actually we found out that inside quadrilateral BCOM we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrilateral BCOM as a rectangle. So we write it down, quadrilateral BCOM is a rectangle. Repeat again. Quadrilateral BCOM is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle BCOM, side BC must be equal to side OM. Repeat again. In rectangle BCOM, side BC must be equal to side OM. But according to what is given us in the question, side BC equals to 9 units. So we can write here that BC equals to 9. And from this equation, 9 equals to BC equals to OM, we derive that side OM is also equals to 9 units. Okay, side OM equals to 9 units. And write here that OM equals to 9 units. And side OM equals to 9 units. Okay. Here it is given us the question that CD is a straight line, and when we extended the straight line CD by a straight line, the result is CM, and when you extend a straight line by a straight line, the result must be a straight line, therefore CM must be a straight line. Okay, so I write it down that CM is a straight line. CM is a straight line. And we have rule number 3 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. Here, CD is a straight line. CD is a straight line, so if we focus on the upper side of the straight line CD at point O, here the sum of the angles must be equal to 180 degrees. So which angles we have on the upper side of CD at point O? We have here this angle alpha and this angle beta. So in total the sum of those two angles must be equal to 180 degrees. So so according to rule number 3, alpha plus beta must be equal to 180 degrees. So we actually can implement rule number 3 in our drawing, because in our drawing we have the straight line CM. So if we focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at this side of CM at point D, we have this angle that is equal to 90 degrees plus this angle that is actually angle LDM. In total, the sum of those two angles must be equal to 360 degrees according to rule number 3. And repeat again, 90 degrees plus the size of angle LDM must be equal to 180 degrees according to rule number 3. Okay, so here we subtract 90 degrees from this equation and we get that the missing angle LDM equals to 180 degrees minus 90 degrees. It is equal to 90 degrees. So we found out that the missing angle equals to 90 degrees. Here, this angle equals to 90 degrees. Likewise, OF is the radius of the quarter circle, therefore it is absolutely a straight line. So you can write down that OF is a straight line. It's the radius of the quarter circle, it must be a straight line. OF is a straight line. So if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees according to rule number 3. So which angles we have at the upper side of OF at point M? We have here this angle that is equal to 90 degrees plus this angle that is actually angle DMF. In total, the sum of those two angles must be equal to 180 degrees. Repeat again, 90 degrees plus angle MDF must be equal to 180 degrees according to rule number 3. Here we subtract 90 degrees from this equation and we get that the missing angle DMF is equal to 180 degrees minus 90 degrees. It is equal to 90 degrees. Okay, so if I know that this angle DMF equals to 90 degrees. This is the right angle. So in the next step, we do a construction from point L. We draw perpendicular on the radius OF. So here, this angle equals to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point L and OF as point N. Point N is the touching point from the perpendicular from point L and OF. Okay, so by drawing the perpendicular from point L, we created the quadrilateral DLMN, and inside quadrilateral DLMN have 1, 2, 3 right angles. So repeat again, inside quadrilateral DLMN, we have 1, 2, 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees. Plus the size of the fourth angle, that is actual angle DLN. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Okay. So here we subtract 270 degrees from this equation, and we get that according to this equation, the missing angle, angle DLN, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. So we can find out that this angle, it is the right angle, it is equal to 90 degrees. Therefore, actually, we found out that inside quadrilateral DLMN, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate to quadrilateral DLMN as a rectangle. Repeat again, quadrilateral DLMN is a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, side DL must be equal to side MN. But according to what is given as the question, side DL equals to 12 units. So here, from this equation, 12 equals to DL equals to MN. We will derive that side MN is also equals to 12 units. Okay. Side MN equals to 12 units. In the next step, we will define side DM as H. According to the same rule that the opposite sides of a rectangle are equal to each other, we get that side DM equals to LN. Side DM equals to LN. But according to our definition, side DM equals to H. So we can write here that DM equals to H. And from this equation, H equals to DM equals to NN, we derive that side NN is also equals to H. Side NN equals to H. In the next step, we'll join points O and C together by a straight line. Here point O is the center of the quarter circle, point C is the point of the quarter circle itself. Therefore, OC is the radius of the quarter circle that is equal to R according to our definition. So in the next step, we'll implement the Pythagoras theorem on the right joint triangle, triangle MOC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, here the square of the hypotenuse is OC square. And it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to OM square plus OM square plus MC square. Okay, MC square. So in conclusion, found out that according to question number 1, OC square equals to MO, it is MO square. Oh, actually it is OM square is plus MC square. So OC equals to R, therefore OC square is R square. And it is equal to OM square. Here OM equals to 9, therefore OM square is 9 squared, it is 81. Plus MC square. What is the length of MC? MC equals to CO plus, actually MC equals to CD plus DM. That is to say, CM equals to CD, that is 16, plus DM, that is 8. So in total, CM equals to 16 plus 8. And therefore, MC square will be equal to 16 plus 8 square. So in conclusion, we found out that according to question number 2, R square equals to 81 plus 16 plus 8 square. Here we will open the brackets on this side of the question and question number 1, and we get that according to question number 1, R square equals to 81 plus 16 square is 256 plus 8 square plus 2 times 16 is 32, and 32 times 8 is 32H. So in conclusion, I found out that according to question number 1, R square equals to 256, 81 plus 250, R square equals to 81 plus 256 plus 8 square plus 32H. So here 81 plus 256 is 337, so we write it down. Plus 8 square plus 32H. Okay. Repeat again, according to equation number 1, r squared equals to 337 plus h squared plus 32h. In the next step, we'll join points O and L together by a straight line. So what is the definition of OL? Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. Therefore, OL is the radius of the quarter circle. That is equal to R according to our definition. In the next step, we'll implement the Pythagoras theorem on the right orange triangle O and L. Here, the hypotenuse OL equals to R. So according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OL square equals to ln square plus ON square. Okay. So ON equals to R, therefore OL square will be equal to R square. And it is equal to ln square. Here ln is equal to h, so ln square is h square plus ON square. ON equals to 9 plus 12, that is 21, therefore ON square will be equal to 21 square. So according to question number 2, found out that R square equals to H square plus 21 square. 21 square is 441, so I write it down. So R square equals to H square plus 21 square is 441. So we have two different expressions for R square. The next step we create equation number 1, this equation number 3 that states that R square according to equation number 1 must be equal to R square according to equation number 2. So R square according to equation number 1 is equal to 300 37 plus L squared plus 32H, and it must be equal to R squared according to equation number 2, that is equal to H squared plus 441. So here you have H squared on both sides of equation number 1, so H squared will get cancelled. What is left from equation number 2 after we cancel H squared? Here we have so we have in this side of the equation 337 plus 32H, that is equal to 441. So here we subtract 337 from this equation number 3, and we get that according to equation number 3, (32H) equals to 441 minus 337 is 104. So found out that according to equation number 3, 32H equals to 104. Here we divide this equation number 3 by 32, and we get that H equals to 104 over 32. That is actually equals to 3.25 units. Okay. Found out that H equals to 3.25 units. In the next step, we substitute H in equation number 2 by 3.25 units. So according to equation number 2, we found out that R squared equals to H squared plus 441. So here R squared equals to H squared H equals to 3.25, therefore H squared will be equal to 10.5625. Plus 441. So R squared equals to 441 plus 10.5625 equals to 541.5625. Here we take out all of this equation number 3, and we get that the radius of the quarter circle R equals to the square root of 541.5625 is equal to 19.25 units. Okay, repeat again. The answer to this question is that the radius of the square root of 541.5625, it is equal to 21.25 units. Okay, so if I found out that the radius of the quarter circle equals to 21.25 units, that is a little bit longer than line segment ON, that is equal to 21 units. Okay, so we finished with the first question. In the next step, I present to you the second question, and we'll solve the second question in two different methods. In the drawing, we have triangle ABC. Side AB equals to x plus y units, side AC equals to y units, side DC equals to x, angle ACB equals to 40 degrees, and angle ADC equals to 80 degrees, and we are looking for the size of this angle theta. So in the first method, we will do a construction, we will extend side BC in y units. So if this point equals to E, then actually here side CE equals to y units according to our construction. We join points A and D together by a straight line. So here we created triangle ACE, so I copy triangle ACE and we analyze triangle ACE. So this is triangle HCE that I copied from the original drawing. Those two sides are equal to each other. They're both equal to y, therefore they are equal to each other. So I can write down that side AC equals to side CE. They're both equal to y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides, they must be equal to each other. So here, angle CAE must be equal to this angle, that is actually angle CEA. Okay. So if we define this angle as alpha, here angle CAE equals to alpha according to our definition, then from this equation alpha equals to CAE equals to CEA, we will derive that angle CEA is also equals to alpha. So this angle is also equals to alpha. In the next step, I will copy angle ACB, this angle that is equal to 40 degrees in this triangle. So this is angle ACB that is equal to 40 degrees according to what is given as the question. And I will present to you the exterior angle theorem. What is the exterior angle theorem? The exterior angle theorem is true in any triangle so here, if we have triangle ABC that could be any triangle, this is triangle ABC. Triangle ABC, this angle equals to alpha, this angle equals to beta, and this angle equals to gamma. Those angles alpha, beta, and gamma are defined as in interior angles because they are located inside triangle ABC, while this angle ACD, this angle is defined as an exterior angle because it is located outside triangle ABC. So we define this angle as angle E. So angle ACD that is equal to E, it is the exterior angle of triangle ABC. And according to the exterior angle theorem, we get that the size of the exterior angle E, it is equal to the sum of the two interior angles that are not adjacent to it. Repeat again, the size of this angle E according to the exterior angle theorem, it is equal to the sum of the two interior angles that are not adjacent to it. Here, angle gamma is adjacent to angle E, and the two other interior angles that are not adjacent to it are alpha and beta, and the sum of alpha and beta is alpha plus beta. So that is to say the side of angle E is equal to alpha plus beta, that is the sum of the two interior angles that are not adjacent to it. Okay, so we implement the exterior angle theorem in triangle ACE. We have the exterior angle ACB. So here, the size of the exterior angle ACB will be equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to the exterior angle ACB, and the two other exterior angles and the two other interior angles that are not adjacent to it are alpha and alpha. So, and the sum of those two angles, it is equal to alpha plus alpha. That is actually 2 alpha. Okay, so this equation is the implementation of the exterior angle theorem in our triangle ACE. Here, according to what is given as the question, angle ACB equals to 40 degrees. So, and from this long equation, 40 degrees equals to angle ACB equals to alpha plus alpha equals to 2 alpha, we will derive that 40 degrees equals to 2 alpha. 40 degrees equals to 2 alpha. Here we divide this equation by 2 and we get that alpha equals to 20 degrees. Okay, alpha equals to 20 degrees. So here angle angle CEA, this angle equals to alpha, so therefore it is equal to 20 degrees. And angle angle CEA, it is also equal to alpha, that is equal to 20 degrees. Okay, in the next step, we focus on triangle ADC. In triangle ADC, this angle equals to 80 degrees, this angle equals to 40 degrees. The sum of those two angles is 120 degrees. Therefore, the third angle must be equal to 60 degrees because of the fact that the sum of the angles in any triangle is equal to 180 degrees, and 60 degrees plus 120 degrees, it is equal to 180 degrees. In the next step, I copy triangle ADE in a new page, and we will analyze triangle ADE. Angle DAE equals to 60 degrees plus 20 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. What is the size of side DE? So from the drawing it is easy to see that DE equals to DC plus CE. Again, DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. So if we found out that DE equals to X plus Y. Okay, this is triangle ADE that they copied from the original drawing. Just like now found out that D equals to X plus Y. In triangle ADE, those two angles are equal to each other, they are both equal to 80 degrees, therefore they are equal to each other. And we have the rule that in front of equal angles in the triangle, they are equal sides. So here, in front of this angle, we have side DE, and in front of this angle, we have side AE, and those two sides must be equal to each other because they are located in front of equal angles. So DE equals to AE. But we have already found out that DE equals to X plus Y. So from this expression, DE equals to X plus Y equals to D equals to AE, we will derive that AE is also equals to X plus Y. Okay, AE equals to X plus Y. In the next step, I'll copy triangle ABE in this page and we'll analyze triangle ABE. Just like now found out that A equals to X plus Y. So I can write here that A equals to x plus y. It has given us the question that AB also equals to x plus y. This angle equals to theta according to what is given us the question, and this angle equals to 20 degrees according to what we have already found out. So this is triangle ABE that I copied from the original drawing. Those two sides, they are both equal to x plus y, therefore they are equal to each other. So I write it down. Side AB equals to side AE, and they're both equal to x plus y, therefore they are equal to each other. And we have the rule that in front of equal sides in the triangle there are equal angles. So here, in front of this side, we have angle theta. In front of this side, we have this angle that is equal to 20 degrees. And according to the rule that I mentioned, those two angles must be equal to each other. Why? Because they are located in front of equal sides. That is to say, angle theta equals to 20 degrees. And that is the answer to the question. So we finished with the first question. In the next step I present to you, we finished with the first method. In the next step I present to you the second method. In the second method, we'll focus on triangle ADC. This angle equals to 80 degrees, this angle equals to 40 degrees, and the sum of those two angles is 80 degrees plus 40 degrees is 120 degrees. So the third angle must be equal to 60 degrees, because 60 degrees plus 120 degrees is 180 degrees, and this is the sum of the angles in any triangle. Here we'll define side AD as A. In the next step, I present to you the law of sines, and we'll implement the law of sines in our triangle. So, what is the law of sines? The law of sines is true in any triangle. So, if you have triangle ABC, that could be any triangle. This is triangle ABC. In triangle ABC, side BC equals to A units in size, and angle BAC equals to A degrees in its size. Side AC equals to B units in its length, and angle ABC equals to B degrees in its size. And finally, side AB equals to C units in its length, and angle ACB equals to C degrees in its size. Capital C degrees in its size. So according to the law of sines, we'll get that A over sine A equals to B over sine B, and it is equal to C over sine C. Okay. Repeat again, according to the law of sines, in triangle ABC, that could be any triangle, A over sine A equals to B over sine B equals to C over sine C. We'll implement the law of sines in the great triangle ADC. In the great triangle ADC, according to the law of sines, we'll get that DC over sinus 60 degrees, DC over sinus 60 degrees equals to AD over sinus 40 degrees and it is equal to AC over sinus 80 degrees. So here equation number 1 is the implementation of the laws of sines in the great triangle ADC. Here DC equals to x, so we substitute DC by x, and we get that according to equation number 1, x over sinus 60 degrees equals to AD equals to A, so we substitute AD by A, and we get that A over sinus 40 degrees is equal to AC equals to Y, so we substitute AC by Y, and we get that it is here Y over sinus 80 degrees. So here we have three expressions that are all equal to each other, so we define the value of each other as K, and we derive the first equation. This expression equals to K. Okay, so x over sinus 60 degrees equals to K. Here we multiply this equation number 1 by sinus 60 degrees, and we get that according to equation number 1, x equals to K times sinus 60 degrees. Okay. In the next step, we will derive the second equation from this longer equation number 1. Here, those two expressions are equal to each other. That is to say, here A over sinus 40 degrees is equal to K. Here we multiply this equation number 2 by sinus 40 degrees, and we get that according to equation number 2, equals to k times sinus 40 degrees. Okay. And finally, we derive the further question. It will be the further question that those two expressions are equal to each other. So y, little question number 3, y over sinus 80 degrees equals to k we multiply this equation by sinus 80 degrees and we get that y equals to k times sinus 80 degrees. Okay. The next step, we find the size of this angle ADB. BC is one side of triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees according to rule number 3. Here this angle equals to 80 degrees plus this angle ADB. In total, the sum of those two angles must be equal to 180 degrees according to rule number 3. So because of the fact that this angle equals to 80 degrees, this angle must be equal to 100 degrees. Because 100 degrees plus 80 degrees equals to 180 degrees. That is the sum of the angles in the upper side of triangle ABC according to rule number 3. So in the next step, we'll focus on the orange triangle ABD, and we'll implement the law of sines in the orange triangle ADB. So here, according to the law of sines in triangle ADB, AD over sinus theta equals to AB over sinus 100 degrees. Okay, question number 2 is the implementation of the law of sines in the orange triangle. We substitute AD by A. So it is A over sinus 100 degrees. That is equal to AB. We substitute AB by x plus y. So it is x plus y over sinus 100 degrees. Here, the question number 2, we substitute A by K times sinus 40 degrees over sinus 100 degrees. And it is equal to x plus y over sinus 100 degrees. We substitute x by k times sinus 60 degrees plus y. We substitute y by k times sinus 80 degrees. All divided by sinus 100 degrees. So here we have k on both sides of the equation, so k will get cancelled. What is left for equation number 2 after we cancelled k? What is left is actually we have here sinus according to equation number 2, found out that sinus 40 over sinus 100, sinus 40 degrees over sinus 100 degrees equals to sinus 60 degrees plus sinus 80 degrees over here it is actually sinus 80 over sinus theta. Here it is also 80 sinus 40 degrees over sinus theta. So it is actually sinus 40 degrees over sinus theta, that is equal to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2, and we get that according to equation number 2, sinus 40 times sinus 100, sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Here we divide this equation number 2 by sinus 80 degrees plus sinus 60 degrees, and we get that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 60 degrees over sinus 80 degrees plus sinus 60 degrees. And present to you the second trigonometric identity. It is actually 2 times sine A cosine A is equal to sine 2A. We use this trigonometric identity to the value of sinus 40 degrees. Here sinus 40 degrees, it is equal to sinus 2 times 20 degrees, that is actually equals to 2 times sinus 20 degrees times cosine 20 degrees. So in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay. I present to you the second trigonometric identity. It's sinus 90 degrees plus theta equals to sinus theta. Repeat again, the trigonometric identity states that sinus 90 degrees plus theta equals to sinus theta. We'll use this trigonometric identity for the value of sinus 100 degrees. According here, sinus 100 degrees equals to sinus 90 degrees plus 10 degrees. And according to this trigonometric identity, the sinus 90 degrees plus theta equals to sinus theta. We get that sinus 90 degrees plus 10 degrees equals to, actually sinus 90 degrees plus theta equals to cosine theta. This is the trigonometric identity. And according to this trigonometric identity, sinus 90 degrees plus theta will be equal to cosine 10 degrees. Now we'll substitute, so in conclusion, found out that sinus 100 degrees equals to cosine 10 degrees. Now we'll substitute sinus 100 degrees by cosine 10 degrees, and we'll substitute sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees in equation number 2. So according to equation number 2, sinus theta equals to sinus 40 degrees, but we already found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees, and we have to multiply it by sinus 100 degrees, and we already found out that sinus 100 degrees equals to cosine 10 degrees, therefore we substitute sinus 100 degrees in equation number 2 by cosine 10 degrees, and we have to divide all by sinus 80 degrees plus sinus 60 degrees. Now I present to you the trigonometric identity for the value of sinus 80 degrees plus sinus 60 degrees. According to the following trigonometric identity, sinus D plus sinus C equals to 2 times sinus D plus C over 2 over cosine D minus C over 2. Okay. We we use this trigonometric identity in order to find out the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we get that the value of sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c. D is 80, c is 60, so 80 plus 60 is 140, and 140 over 2 is 70. So here you have 70 degrees times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we substitute sinus 80 degrees plus sinus 60 degrees in equation number 2 here by 2 times sinus 70 degrees times cosine 10 degrees. And we get that according to equation number 2, sinus theta equals to 2 times sinus 20 degrees times cosine 20 degrees times cosine 10 degrees over sinus 80 degrees plus sinus 60 degrees, but we just right now found out that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Okay? So we substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So what is left from equation number 2 after we cancel those 2 expressions here? What is left here, that it is actually we have here, this side of the equation, sinus theta, that is equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. In the next step, I present to you the last trigonometric identity. I will use the trigonometric identity for sinus 70 degrees. The trigonometric identity states that sinus 90 degrees minus theta equals to cosine theta. Sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and according to this trigonometric identity, sinus 90 degrees minus theta equals to cosine theta. We get that sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees. So in conclusion, found out that sinus 70 degrees equals to cosine 20 degrees, and now we substitute sinus 70 degrees in equation number 2 by cosine 20 degrees, and we get that according to equation number 2, sinus theta equals to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. But we just right now found out that sinus 70 degrees equals to cosine 20 degrees, so we substitute sinus 70 degrees for cosine 20 degrees. So here we have cosine 20 degrees in the numerator, and we have cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. And what is left from equation number 2 after we cancel cosine 20 degrees? What is left is actually we have here sinus theta, and then equation number 2, sinus theta equals to sinus 20 degrees, and we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. So if sinus theta equals to 20 degrees, it means that theta equals to 20 degrees. So we found out that according to the second method, also that theta equals to 20 degrees. So we finish with the second method. In the next step, we'll summarize the lecture. We start with the first question, of course. In the drawing, we have a quarter circle. Line segment AC equals to 9 units, line segment CD equals to 16 units, line segment DL equals to 12 units, this angle equals to 90 degrees, this angle also equals to 90 degrees, and this angle against CDL also equals to 90 degrees, and our mission is to find out the radius of this quarter circle. So, first of all, because of the fact that this is a quarter circle, it means that point O is the center of the quarter circle, this angle equals to 90 degrees, and side AO equals to side OF, and the both sides equals to the radii of this quarter circle, that is equal to 1 according to our definition. So in the next step, we extended the straight line CD, straight line, until it touches the point, until it touches side OF at point M. In this way, we created a triangle, a quadrilateral BCOM, and inside quadrilateral BCOM, we have 1, 2 right angles. And the sum of right angles is 90 times 3 is 270 degrees, plus the size of the fourth angle, that is actually angle DMO. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation, and found out that the missing angle, angle DMO, equals to 90 degrees. So this angle, the missing angle equals to 90 degrees. So we found out that inside quadrilateral BCMO, we have 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So we will relate quadrilateral BCOM as a rectangle. But we also know that the opposite sides of a rectangle are equal to each other. That's to say, side BC must be equal to side OM. BC equals to OM, but it's given us the equation that BC equals to 9. So from this equation, 9 equals to BC equals to OM, we derive that side OM is also equals to 9 units. Here side OM equals to 9 units. Here it is given us the equation that CD is a straight line, and when we extended the straight line CD by a straight line, the result must be a straight line. So the result is CM, and the result must be a straight line. So CM, because when you extend a straight line by a straight line, the result must be a straight line. So CM must be a straight line. So if you, and then I presented to you all number 3 that states that the sum of the angles on one side of a triangle and the sum of the angles on one side of a straight line is equal to 180 degrees. So if you focus on this side of the straight line CM at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have here? This angle is 90 degrees plus angle LDM. In total, the sum of those two angles must be equal to 180 degrees. Okay, here 90 degrees plus angle LDM must be equal to 180 degrees according to rule number 3. Here we subtracted 90 degrees from this equation and found out that the missing angle LDM equals to 180 degrees minus 90 degrees. It is equal to 90 degrees. So this angle equals to 90 degrees. Likewise, we know that OF is the radius of the quarter circle, therefore OF, it is absolutely a straight line. Okay, here OF is a straight line, as a radius it must be a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees, so if we focus on the upper side of the straight line OF at point M, here the sum of the angles must be equal to 180 degrees. So which angles we have? At the upper side of OF at point M, we have this angle that is equal to 90 degrees plus angle OMN. In total, they must be equal to 180 degrees. Here, 90 degrees plus angle DMF must be equal to 180 degrees. We subtracted 90 degrees from this equation and we found out that the missing angle DMF equals to 180 degrees minus 90 degrees. It is equal to 90 degrees. So this angle is the right angle, it is equal to 90 degrees. Then we did the construction from point L, we drew perpendicular on OF, that is to say this angle equals to 90 degrees according to our construction. And we defined the touching point of the perpendicular from point L and OF as N. So here we created quadrilateral OLMN, and inside quadrilateral OLMN we have 1, 2 free right angles. And the sum of free right angles is 270 degrees. So 270 degrees plus the size of the fourth angle in total must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle, this angle DNN, equals to 360 degrees minus 270 degrees. It is equal to 90 degrees. It is the right angle. Okay. So we actually found out that inside quadrilateral DLMN we have 4 right angles. And then quadrilateral that has 4 right angles must be at least a left angle if not a square. So we found out that quadrilateral DLMN is a left angle, or we relate to quadrilateral DLMN as a left angle, and we know that the opposite sides of left angle are equal to each other. That is to say in left angle DLMN, side DL must be equal to side MN. DL must be equal to MN. But here DL equals to 12 units. So we can write here DL equals to 12 units, and for this equation 12 equals to DL equals to MN, we will derive the side MN is also equals to 12 units. Here side MN equals to 12 units. Okay. Then the next step we defined angle DM as H. And according to the same rule that the opposite sides of left angle are equal to each other, we will get that DM equals to LF. DM equals to LN, of course. But according to our definition, DM equals to H. So from this equation, H equals to DM equals to LN, we will derive that NN is also equals to H. Okay, then join point C and O together by a straight line. Point O is the center of the quarter circle. Point C is the point on the quarter circle itself. This is exactly the definition of a radius. That is to say, OC is the radius of the quarter circle that is equal to R according to our definition. So we implemented the Pythagoras theorem on the right green triangle OCM. According to the Pythagoras theorem, OC square equals to OM square plus MO square. Repeat again, OC square equals to OM square plus MC square. According to the Pythagoras theorem, OC equals to R, so OC square is R square, OM equals to 9, so OM square is 9 squared, that is 81, plus CM. CM is 16 plus H, therefore CM square is 16 plus h squared. Here we open the brackets on this side of equation number 1 and we found out that r squared equals to 81 plus 16 plus h squared is 16 squared, that is 256 plus h squared plus 2 times 16 is 32 and 42 times h is 32h. So in conclusion, we found out that r squared equals to 81 plus 256 plus h squared plus 32h. Here 256 plus 81 equals to 337. So according to equation number 1, we found out that r squared equals to 337 plus h squared plus 32h. In the next step, we join points O and L together by a straight line. Point O is the center of the quarter circle. Point L is the point of the quarter circle itself. And that is exactly the definition of a radius. That is to say, OL is the radius of this quarter circle that is equal to R according to our definition. So OL equals to R. Then we implemented the Pythagoras theorem on the orange right triangle, triangle ONL. According to the Pythagoras theorem, OL squared equals to LN squared plus ON squared. Again, OL squared equals to LN squared plus NO squared. OL equals to R, therefore OL equals to R, therefore OL squared is R squared. LN equals to H, therefore LN squared will be equal to H squared. NO equals to 9 plus 12, that is 21, and ON squared will be equal to 21 squared. So in conclusion, found out that R squared equals to H squared plus 21 squared. So here, 21 squared is 441. So in conclusion, according to equation number 2, we found out that R squared equals to H squared plus 441. So we have two different expressions for R squared. Therefore, we can create equation number 3 that states that r squared according to equation number 1 must be equal to r squared according to equation number 2. R squared according to equation number 1 is 337 plus h squared plus 32h, and it must be equal to r squared according to equation number 2, that is equal to h squared plus 441. Here we have h squared on both sides of the equation, so h squared will get cancelled. And we found out that according to equation number 2, 337 plus 32h equals to 441. We subtracted 337 from this equation and found out that 32h equals to 104. Okay. Here we divided this equation number 3 by 32 and found out that h equals to 104 over 32, that is 3.25 units. In the next step, we've substituted h in equation number 2 by 3.25 units. Here, according to equation number 2, r squared equals to h squared plus 441. So if h equals to 3.25, it means that h squared will be equal to 3.25 squared. That is 10.5625. So in conclusion, we found out that r squared equals to 10.5625 plus 441. That is actually equals to 541.5625. So here we took out of this equation number 3, and found out that the square root of 451.5625 is equal to 21.25 units. We finished with the first question. In the next step, I presented to you the second question, and we solved the second question in two different methods. Here we have triangle ABC. Side AB equals to x plus y. Side AC equals to y, side DC equals to x, this angle equals 40 degrees, this angle equals 20 degrees, and this angle is theta. That is the angle that we are looking for. Our mission is to find out the size of this angle theta. So here we did the construction, we extended side BC in y units, that is to say CE equals to y units according to our construction. Then we joined points A and D together by a straight line, and then I copied triangle ACE in a new page and analyzed triangle ACE. So this is triangle ACE. This is the coverage of the original drawing. Side CE equals to Y according to our construction. Side AC equals to Y according to what is given as the question. So those two sides are both equal to Y, therefore they are equal to each other. That is to say, AC equals to C equals to Y. We have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is alpha, then the other angle must be also equal to alpha. Then I copied angle ACB that is equal to 40 degrees from the original drawing, and I presented to you the external angle theorem, and we implemented the external angle theorem in triangle ABC. So what is the external? We implemented the external angle theorem in triangle ACE. What is the external angle theorem? The external angle theorem is true in any triangle. So here we have a triangle ABC. It could be any triangle. In triangle ABC, we have angles alpha, beta, and gamma that are defined as interior angles. While this angle, angle AC, D that is equal to A, it is defined as an exterior angle because of the fact that it is located outside triangle ABC. So what is the size of the exterior angle, angle E? The size of the exterior angle, angle E will be equal to the sum of the two interior angles that are not adjacent to it. This angle, angle gamma, adjacent to angle E, and the two other interior angles that are not adjacent to it are those two angles, alpha and beta. So therefore, angle E equals to alpha plus beta according to exterior angle theorem. We implemented the exterior angle theorem in triangle ACE. Here, the exterior angle ACE will be equal, according to the exterior angle theorem, will be equal to the sum of the two interior angles that are not adjacent to it. This angle is adjacent to this angle. The two other interior angles that are not adjacent to it are those two angles that are both alpha. So it is alpha plus alpha, and according to the exterior angle theorem, we get that the size of the exterior angle, angle C, will be equal to alpha plus alpha. That is the sum of the two interior angles that are not adjacent to it. Alpha plus alpha is 2 alpha, and it is given as the equation that angle ACB equals to 40 degrees. So from this long equation, we will conclude that 40 degrees equals to 2 alpha. Here we divided this equation by 2 and found out that angle alpha equals to 20 degrees. So here, this angle, this actual angle alpha equals to 20 degrees, and this angle that is also angle alpha equals also to 20 degrees. Then we focus on triangle ADC, and here this angle equals to 80 degrees, this angle equals to 40 degrees. So in total the sum of those two angles is 120 degrees, so therefore this angle must be equal to 60 degrees, because 60 degrees plus 120 degrees will be equal to 180 degrees. That is the sum of the angles in any triangle. Then I copied triangle ADE in a new page, and we actually analyze triangle ADE. This is triangle ADE, that is a copy of the original drawing. This angle, angle DAE equals to 60 degrees plus 30 degrees, that is 80 degrees. This angle equals to 80 degrees according to what is given as the question. What is the size of DE? DE equals to DC plus CE, that is to say DE equals to DC, that is X, plus CE, that is Y. So in conclusion, hold on, that DE equals to X plus Y, DE equals to X plus Y, and those two angles are equal to each other, and we have the rule that in front of equal angles in the triangle, there are equal sides. So this angle is located in front side DE, while this angle is located in front of side AE. And those two sides must be equal to each other according to the rule that I mentioned, that in front of equal angles in the triangle, there are equal sides. So DE must be equal to AE. But we have only found out that DE equals to X plus Y. So you can write here that DE equals to X plus Y. And from this equation, X plus Y equals to DE equals to AE, we will derive that side AE is also equals to X plus Y. Then I copy triangle ABE in this new page and analyze triangle ABE. Side AB equals to X plus Y according to what is given as the equation. We will just right now found out that side A equals also to X plus Y. This angle equals to to theta according to what is given as the question, and this angle equals to 20 degrees according to what we already found out. So those two sides are both equal to x plus y, therefore they are equal to each other. Okay, AB equals to AE. And we have the rule that in front of equal sides in the triangle there are equal angles. In front of this side AE we have angle theta. In front of this side AB we have 20 degrees. So those two angles must be equal to each other according to the rule that I mentioned. That is to say, angle theta equals to 20 degrees. We finished with the first method, then I presented to you the second method. In the second method, we focus on triangle ADC. This angle equals to 80 degrees. This angle equals to 40 degrees. 40 degrees plus 80 degrees, that is the sum of those two angles, is 120 degrees. So this angle, the third angle, must be equal to 60 degrees. For 60 degrees plus 120 degrees is 180 degrees. That is the sum of the angles in a triangle. Then we define side AD as A, and then I presented to you the law of sines, and we implemented the law of sines in our triangle. According to the law of sines, in this triangle ABC, A over sinus A equals to B over sinus B equals to C over sinus C. Then we implemented the law of sines in the green triangle ADC. According to the law of sines, we get that DC over sinus 60 degrees equals to dA over sinus 40 degrees, and it is equal to AC over sinus 80 degrees. We substituted DC by X, we substituted AD by A, and we substituted AC by Y. And we got this expression. We have three expressions that are all equal to each other, so we define the value of them as K. The value of each of them as K. We derive the first equation from this long equation. That is to say, according to equation number 1, those two expressions are equal to each other. That is to say, x over sinus 60 degrees equals to K. We multiply this equation by sinus 60 degrees and found out that x equals to K times sinus 60 degrees. Then we derive the second equation from this long equation. Those two expressions are also equal to each other. That is to say, A over sinus 40 degrees equals to K. So here we multiply this equation by sinus 40 degrees and found out that A equals to K times sinus 40 degrees. And finally, those two expressions are also equal to each other, so we can write down that according to equation number 3, y over sinus 80 degrees equals to K. We multiply this equation by sinus 80 degrees and found out that y equals to K times sinus 80 degrees. And then we found out the value of this angle. BC is one side of triangle ABC, therefore it is absolutely a straight line. If we focus on the upper side of the straight line BC at point D, here the sum of the angles must be equal to 180 degrees. This angle equals to 80 degrees, and plus this angle, in total they must be equal to 180 degrees. So if this angle equals to 80 degrees, it means that this angle must be equal to 100 degrees, because 100 degrees plus 80 degrees, it is equal to 180 degrees. That is the sum of the angles on one side of a straight line. Okay, so this angle equals to 100 degrees. Then we implemented the law of sines in the orange triangle ABD. According to the law of sines in the orange triangle ABD, ABD, AD over sinus theta equals to AB over sinus 100 degrees. Okay, here AD equals to A, so we substitute AD by A. AB equals to x plus y, so we substitute AB by x plus y, and we got that A over sinus theta equals 4x plus y over sinus 100 degrees. Here, we substitute A by K times sinus 40 degrees. We substitute A by K times sinus 60 degrees, and we substitute Y by K times sinus 80 degrees, and we got this expression. We have K on both sides of the equation, so K will get cancelled. And after we cancel K, we got this equation number 2 that states that sinus 40 degrees over sinus theta equals to sinus 60 degrees plus sinus 80 degrees over sinus 100 degrees. Here we cross multiply this equation number 2, and found out that sinus 40 degrees times sinus 100 degrees equals to sinus theta times sinus 60 degrees plus sinus 80 degrees. Okay. Here we divided this equation number 2 by sinus 60 degrees plus sinus 80 degrees, and we got this equation that sinus theta equals to sinus 40 degrees times sinus 100 degrees over sinus 80 degrees plus sinus 60 degrees. We have the trigonometric identity that sinus 2a equals to 2 sin a cosine a. We use this trigonometric identity for sinus 40 degrees. Sinus 40 degrees equals to sinus 2 times 20 degrees. And according to this trigonometric identity, sinus 2 times 20 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay, so in conclusion, we found out that sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Then we have the trigonometric identity that sinus 20 degrees plus theta equals to cosine theta. So according and we know that sinus 100 degrees is sinus 90 degrees plus 10 degrees. And according to this trigonometric identity, sinus 90 degrees plus theta will be equal to cosine sinus 90 degrees plus 10 degrees equals to cosine 10 degrees. So in conclusion, we found out that sinus 100 degrees equals to cosine 10 degrees, while sinus 40 degrees equals to 2 times sinus 20 degrees times cosine 20 degrees. Okay. So here we substituted sinus 40 degrees by 2 times sinus 20 degrees times cosine 20 degrees, and we substituted sinus 100 degrees in this equation number 2 by cosine 10 degrees, and we divided all by sinus 80 degrees plus sinus 60 degrees. Here we have the trigonometric identity that states that sinus d plus sinus c equals to 2 times sinus d plus c over 2 times cosine d minus c over 2. We use this trigonometric identity to find the value of sinus 80 degrees plus sinus 60 degrees. According to this trigonometric identity, we get that sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus d plus c is 80 plus 60 is 140, and 140 over 2 is 70, times cosine d minus c. D is 80, c is 60, so 80 minus 60 is 20, and 20 over 2 is 10. So in conclusion, we found out that sinus 80 degrees times sinus 80 degrees plus sinus 60 degrees equals to 2 times sinus 70 degrees times cosine 10 degrees. Therefore, we can substitute sinus 80 degrees plus sinus 60 degrees by 2 times sinus 70 degrees times cosine 10 degrees. Actually, we did it. Therefore, in the denominator, instead of sinus 80 degrees plus sinus 60 degrees, we get this expression 2 times sinus 70 degrees times cosine 10 degrees. And the numerator is exactly as it was before. Okay. So here we have cosine 10 degrees in the numerator and cosine 10 degrees in the denominator, so cosine 10 degrees will get cancelled. Here we have 2 in the numerator and 2 in the denominator, so 2 will also get cancelled. What is left from equation number 2 after we cancel those two expressions? What is left is actually we have sinus theta equal to sinus 20 degrees times cosine 20 degrees over sinus 70 degrees. And we have the last trigonometric identity that sinus 90 degrees minus theta equals to cosine theta, we use this trigonometric identity for the value of sinus 70 degrees. Sinus 70 degrees equals to sinus 90 degrees minus 20 degrees, and according to this trigonometric identity, sinus 90 degrees minus theta will be equal to cosine 20 degrees. Sinus 90 degrees minus 20 degrees will be equal to cosine 20 degrees according to this trigonometric identity. So in conclusion, we found out that sinus 70 degrees equals to cosine 20 degrees. That is to say, we can substitute sinus 70 degrees in the denominator of equation number 2 by cosine 20 degrees. We did it, and we got that sinus theta equals to sinus 20 degrees times cosine 20 degrees over cosine 20 degrees. So we have cosine 20 degrees in the denominator of cosine 20 degrees in the denominator, so cosine 20 degrees will get cancelled. So finally, we found out that according to equation number 2, sinus theta equals to sinus 20 degrees, and we have the trigonometric identity that if sinus alpha equals to sinus beta, it means that alpha equals to beta. Therefore, if sinus theta equals to sinus 20 degrees, it means that theta equals to 20 degrees. So in both methods, we found out that the value of theta, the value of this angle theta, it is equal to 20 degrees. Okay, thank you very much.